Hello everyone, my physics experiment is called Weak Wi-Fi, and I'm going to start off with my intro. In this physics experiment, I decided to test the speed of Wi-Fi inside of a microwave with a Faraday cage. This experiment is intended to show you how weaker Faraday cages will be less effective in blocking wireless internet signals to cellular devices. I personally used my iPhone to test this out and proved that more holes in a Faraday cage will increase the speed of Wi-Fi to the phone. Onto my materials. In this experiment, I used 3 different cell phones. One was used for filming, one was used as a timer, and the last was used to measure the speed of Wi-Fi inside of the microwave. I also used aluminum foil as the Faraday cage and a knife to cut the holes. Lastly, I used a ruler to estimate the diameter of the holes. Onto the procedure. I gathered 10 pieces of aluminum foil that are about the same size, then I wrapped my phone in a piece of the foil and placed it in the microwave. I called my phone from a separate device to ensure that the Faraday cage worked in blocking out any kind of Wi-Fi. I then took my phone and cut a single hole about a ½ inch in diameter into the foil after starting a Wi-Fi speed test on the Wi-Fi Sweet Spots app on my phone. I started a timer on a separate device so that I could see when the phone was in the microwave. I let the phone sit for about 10 seconds and stopped the timer, then unwrapped the phone and checked the Wi-Fi speed. I repeated everything starting with wrapping the phone in aluminum foil and added a hole every time until there were 10. You will now be seeing a visual of the process of the experiment and how I recorded my results. First, we're going to see what the megabeats per second are like without any holes in the aluminum. As you can see, the Faraday cage was so strong that it failed to find any connection inside of the aluminum without any holes. I cut a hole in the aluminum about a ½ inch in diameter. I screen recorded on my iPhone to see and look back at the megabeats per second that were recorded while in the microwave, and as you can see at the 45-second mark, it was 0.6 megabeats per second. After using 2 holes, you'll notice that it was 0.7 megabeats per second. After using 3 holes, it was 1.3 megabits per second. With 4 holes, there were 1.4 megabits per second. With 5 holes, there were 2.4 megabits per second. With 6 holes, there were 3.9 megabits per second. With 7 holes, there were 5.8 megabits per second. With 8 holes, there were 10.9 megabits per second. With 9 holes, it was 14.1 megabits per second. And finally, with 10 holes, the Wi-Fi speed measured in at 18.3 megabits per second. This is my data table, including the number of holes in megabits per second, starting with 0 holes going all the way through 10. Here's the graph that was used to accompany the data table. Since there is no equation that's correlated to my experiment, I decided to input my data points into an online equation creator and got this equation down below. It seems very complex, but since there's no equation that can actually be used for this physics experiment, this is about the best we can get. Onto the discussion. I have learned that my hypothesis about megabits per second and number of holes are correlated. Wi-Fi will go slower if more aluminum covers the device in the microwave. This is important knowledge for being aware of where Wi-Fi speeds are stronger and under what conditions. To improve the project in the future, I could try to be more precise with my measurements of the sizes of the holes I cut into the aluminum foil so that I can get more accurate results. I could also try to have a more precise stopwatch so that there are no skews in the graph that could impede on the data. Thank you.